Oh, yeah. Yeah. Okay, so hi everyone. My name is Konstantin. Very happy to welcome you today, this morning in Sydney. So this is the 5th edition of the Beyond Facts workshop. Started 2020. It was COVID back then. So the first time we had this workshop running, it was on Zoom. Now we're also on Zoom, but luckily there are some of you here in the room. So what's this community about? So the interest that we took into is basically looking into the abundance, the big amount of different kind of online discourse information, including claims, different kinds of viewpoints and sources on the web, together with their context, such as the authors of these claims, these associated events, and other entities. And as we have seen, this have been a valuable source of insights for various research into dis and misinformation spread, viewpoint discovery, propaganda discovery, bias in discourse, and whatnot. Right. So we've seen also that a lot of effort in different communities in the field of artificial intelligence have been trying to deal with these issues by developing and applying computational methods, both from natural language processing, but also from other fields like argumentation mining, sentiment detection, and also, of course, knowledge representation. So it's been kind of a joint effort from the various fields from artificial intelligence. And what we have seen is that claims are different from facts. Like there is an inherent difference between claims and facts, right? So what we can consider about claims is that they're more complex in a certain way because, first of all, their veracity is not immediately given, right? So it's a question of context, and when this context evolves dynamically, the veracity of these claims can also evolve and change. So there's a bunch of meanings that can be associated to claims according to their contexts, and these meanings can also change over time. And we can observe some kind of intentionality also in the meaning that these claims are supposed to carry, right? So there are a lot of differences across different communities of how we define what claim is. If you look into argumentation mining or fact checking or question answering, right? So these are different definitions that people use. So we thought it's nice to create a community, a forum where we can talk about these problems and converge maybe towards, or at least discuss these different ways that we model claims and how we use them in order to approach different problems such as what I just mentioned, like fact-checking or mis and disinformation detection. So the idea here is to say, well, can we imagine that we can go towards a web where we are able also to look for information related to claims, not only to facts, which we are more or less able to do nowadays. And this thanks to various kinds of computational methods from the above mentioned fields. So our community is looking into works that are interested in modeling, extraction, and analysis of online discourse. So discourse that can be observed on the web. And we thought that in order to deal with this problem, we need an interdisciplinary community, right? So we need researchers from various fields, as I mentioned, including argumentation mining, stance detection, knowledge and information extraction, fake news detection, disinformation detection, and so on, but also researchers from the symbolic branch of AI who do knowledge representation, knowledge graphs, and ontologies, and so on. So today, what we're going to do, so we have a full day workshop. We're very happy to get lots of really nice and interesting submissions. So we have selected 11 of them. So the day will be quite busy. So as I mentioned, various fields are represented, including NLP, stance detection, semantic web techniques, argumentation mining. Also some a little bit more distant from computer science fields like political science and social sciences. In terms of application, we'll see papers dealing with fact-checking, propaganda detection, recommender systems, emotional dynamics, and also the biomedical field. Well, also this diversity is represented in terms of geography. We have people from various countries across the world, from Europe, USA, UK, Canada, Japan, and so on. So you have some of the keywords that we can find in the papers that were accepted this year for presentation. And since we already have a little bit of delay, I will, with no further ado, present our keynote speaker. So we are very happy to have here today with us Lunwei Ku, who is a research fellow at the Institute of Information Science at Academia Sinica. And she will be talking about questioning truths, sharpening minds, leveraging human questions and LLM in the loop to boost news literacy. So Lunwei, please, the floor is yours. A second. There you go.
Okay, thank you, Konstantin, for your introduction. And good morning, everyone. I'm Lunwei Ku from Academia Sinica. I'm very happy here to introduce some of our work and our idea of all these years we are working on the fake news. So today I'm gonna talk about questioning truths, sharpening minds, leveraging human questions, and LLM in the loop. Most important is the LLM in the loop to boost the news literacy. Okay, so basically this work is from NAACL 2024, and I'm gonna talk about some of our follow-up work, including development in other language environment. As you all know that if we have a fake news system or technology, it's actually very challenging to migrate it to another country or another language because all the cultural difference and language difference and all the conditions in the countries are very different. And then we'll introduce some of the interesting issues we found and some application we are working on right now. Okay, so first of all, this is very commonly seen fake news detector that we can see on the social media or web pages. First is that you can have a tag that's telling you that this is a fake news, or some advanced function that can provide some of the explanation that telling you that, oh, this is a fake news because of this evidence. So these two different methods, we have conducted several experiments to compare them. And for now, it seems that both methods can work. But for the tag, some people think that, well, it's gonna be something like you see it very often and you will feel, okay, I'm just gonna swipe it away and don't wanna see it anymore. So it's not very effective in general, but for the explanation, there are also some drawbacks, like people don't want to really read so long contents and they feel like, oh, it's like too much, or they don't believe what you told them. So here is something that we are trying to do is that we have a fake news, and these fake news affect people. So these people think, oh, it's a real news. And then through these explanations, we want them to correct their perception, not like correct, they understand that this is actually a fake news. So what is the point is that we hope that this explanation is persuasive enough to tell them. But in the past, actually, let me talk about some of the related work later. But first, let's identify this research problem. First is that, okay, we all know that misinformation actually threatens the society, so we need to do something about it. So our approach here is trying to use LLMs. Well, it's the most advanced technology to generate explanations, but not just to generate explanations, but how to generate a good explanations for news claims and refine them and then make them persuasive. So this is our goal. And the most important thing is that we have evaluated our method, this approach, through more than 2,000 participants. So I think it's like the largest experiment so far. And it's a real user study. So we have some interesting conclusion here. And our goal is, of course, to help users that later they can better understand the information in this fake news. Okay, so some related work actually talk about this. First is that's understanding some of the past fact-checking explanations work. Most of them are focusing on summarize the evidence of the real news, like the real side, or some of the evidence that mentioned that which part is wrong in the fake news. And these works, most of the evaluation, they're focusing on how good the quality of this explanation is. Like, for example, is it fluent? Is it correct? But they are not talking about, is this explanation persuasive enough to make the participant change their perception? Okay, and the second related work is about like a large language model. They actually can do like self-refinement, as you all know, that if we generate some explanation, we can use some method to ask the large language model to kind of rewrite it in the direction that we want. So here is the thing that we try to observe which parts is the most important parts that the LM should refine for our persuasive explanation. And the last part is that most of the work, they talk about how to evaluate and analyze the fake news persuasiveness of the explanation. They use the Luke dictionary to see like which part from the psycholinguistics that we can really give a persuasive explanation. Okay, so this is our methodology here. We first conduct our experiment in the English research, English fake news. So as you can see, we collect political fact claims, 50 claims, and then we have this explainer. We give it prompt, and they will generate the initial explanation. Then after that, we have an iterative process that we involve like real human, like real people that talk to the LLM, or it's just an LLM talk to the first explainer. And then this iteration will continue until we generate the explanation we're satisfied with. Okay, so here is some settings here. We have like 3 to 15 rounds. If it's like after 15 rounds, we still cannot get satisfying explanation, we will just stop it. And then we will also have our GPT-4 to summarize all the conversations to generate the final explanation. Okay, this is an example of how we get the initial explanation and what are the refined final round explanation looks like. As you can see here, I want to mention is that the human explanation, the human generated explanation is always shorter and more brief compared to the large language models. So as you can see, like some of the explanation are actually very long. And we also mentioned in the earlier part that people tend to not having so much patience reading the long explanation. However, in our experiment, we showed that the long explanation and short explanation actually in the persuasiveness aspect, they don't really have big difference here. Okay. So here's our data. We do conduct this experiment. So we have news clients from PolitiFact, spanning 2019 to 2021. And we have, like I mentioned, human participants, 2,797 American participants, because we first conduct on the English fake news, and then we do the evaluation experiment. So here, I want to point out that conducting fake news experiment is actually very challenging. First of all, if you collect the past data, most of your participants have heard this fake news. So you need to continue collecting new data. It's really very, hard for experiment. But also because of this, we also found something actually quite scary, is that we can see from the later experiment results that even most people say that they have heard this fake news, they actually still give the wrong answer about the fake news. So this is the kind of like the scary part. Okay. So we have the evidence, we have the support evidence and refute evidence, and we will give this evidence to large language models. So the large language model will generate the explanation in our iterations. Okay, so this is experiment results, as you can see. Well, the details are in our paper, so I will just mention some of the points here. First of all, what we did is that we conduct a pre-test on these participants and ask them what do they think about this fake news. And then we also, after they read these explanations, we conduct another user study and ask them the question again. So if they change their mind, they will give different answers. And in our experiment, we do also a long-term experiment. That is after 48 hours, we ask them again. So it's the thing, like sometimes you read some information and then you change your mind, but because your perception is too strong. So after 48 hours, which is considered a long-term memory in the psychology already. So after 40 hours, you might change back, not like change back, you actually never change your perception. You're just reading this information, and this information gives you some idea, and then you answer immediately according to the information. So in this condition, that situation, actually, it's not helpful for us to make the situation better. So here we conduct these two kinds of experiments. And then here you can see the accurate rate here. As we can see, these the gray parts are the one that after using the refined explanation, you actually has significant better results compared to your initial explanation. So here you can see that using the human and the GPT-4 in the refined condition, in the fake news, for the fake news, actually can help. So in this experiment, we find a very interesting thing is that the behavior of people on the fake news and the real news actually are different. So on the fake news, they like more argumentative explanations. So through these iterations, actually can help a lot to persuade people that this is a fake news. But for the real news, they don't really like this argumentative stuff. And for the real news, what we should do to get the better result is just to summarize them. Summarize the evidence and the real thing in the real news and bring it to the participants, and it's more effective. So this is what we found in this experiment. And then we try to see that what kind of questions for these large language model and people, like real people, they will ask about towards the large language model. So let's remind you that our process again, we have the initial explanation, and then the participants or the LLM, they can give a rating to this explanation. And then they will ask questions like, why do you think it's in this way? Or I don't trust it. You can say anything. And then the large language model will regenerate the explanation according to your challenge. Okay, so this is the iteration process. And what we find here is, according to these circles here, the words are very small, but as you can see, this is palm, Claude, palm, palm. So the bottom line, they are from Claude and Palms. Their questions are not that diverse compared to human-generated question and GPT-4. So here we use Claude 2 and Palm 2 still here. So as you can see here, we will bring you that when we migrate this system to another language, it encounters some issue because of the diversity and the ability of the language model. So here still that we can do this experiment, but we can already see that from Claude and Palm, the generated questions are less diverse. And when they generate less diverse question, we link to the previous results, we can see that the results are less satisfied. Okay. All right. So here we have some findings. The first is that question diversity is really important. So we want the large language model can generate diverse question for challenging. This is the first thing. And the second thing is that if a person is in a neutral position in the very beginning, it's easier to change their perception. This is more like what also conforms to what we understand. If this person is in the very beginning thinking it's fake, you want to change to real, or real to fake, it's harder. But if in the very beginning he's not so sure, he thinks like, oh, it's neutral, or I'm not sure, it's easier. Okay. All right. So this is what we find. And then, so here we have some conclusion for this work, and we'll continue working on follow up this work, is that we know that refinement is effective through these questions. And for some undecided users, this method is very effective. As you can see in the results, it's increased even more than 30% accuracy. So this is like, we think quite useful. And also we think that these methods is also beyond linguistics, because it's not only like focusing on changing the patterns of the words, but on real people or a language model, they challenge on the suspicious points of these explanations. So, okay, here I want to bring up in the past research, there are some research working on the same thing. So they focus on the name entities using language, like natural language processing skills. They're focusing on the name entities because name entities is the most important information in the news articles. They challenge the name entities and the verbs, like the action or the activity. But it's more like not able to bring you more personal persuasiveness. If your person really interact with the explanation, this person can bring up the points that he or she feels suspicious. Okay, so then we want to move this whole methodology to another language and environment. So we adapt this to the traditional Chinese environment in Taiwan where I work. And Taiwan is like confirmed as the most target country by foreign governments spreading false information. So in the research continues for 9 years until 2021, but I'm not sure, like after that, I think it's still top several countries. So we collaborate with the Taiwan Fake News Checking Center. So previous, as you can see in our system, we have the human joining this experiment, but these people, they are like just participants. But here, the people who interact with our large language model, they are expertise. Like they are the people who are writing fake news explanation every day in the fake news checking center. Okay, so Then we design a system. Actually, we have an app. If you're interested, you can play a little bit later. I show you the QR code and you can just use your phone to play with it. And then I want to mention that because now there are a lot of cyber scam right now. So people actually don't know if this is a scam. This is very similar to the fake news. So what we think is that it's also some method that we can also apply on the cyber scam. Okay, so here we compare our previous method, and if we move to another language, as you can see here, we no longer be able to use PaLM 2 and Claude. The problem here is that their language ability is not enough strong to support like multi-turn conversations of question and answering and challenging. We found that in the middle of the conversation, it will stop somehow and will generate weird questions or weird conversations. So this is the thing that why we cannot continue working on it. So in our environment, like traditional Chinese environment, we use only GPT-4. So that also tells us that if the question is not diverse enough, it will generate all the same questions. And if the language ability is not good enough, it cannot really continue this kind of iterative process. Okay, so in this experiment, the follow-up experiment, we try to find what will cause the reduce of the generated text, reduce the quality. So we see that there are hallucinations of the large language models, of course. This is the old issue. And then there are some ambiguity. And sometimes the news is very complicated that you are actually hard to ask a right question. So these are all possible issues that may happen in this flow. So let's see some of the results here. These are the problems that we are trying to analyze and find out that will generate low quality questions. And we find that, of course, some of the language model, as you can see here, the PaLM generate most nonsense questions. So as here, it generates so many nonsense questions so that it really cannot work in this process. And as you can see here, there are some satisfied no question. What does that mean? Because in the iteration, you can say, okay, I'm satisfied. I don't need to ask a question anymore. So like this kind of question. So I don't need to ask question. These questions are generated most by Claude. And as you can see that there are some duplicated questions also generated a lot by PaLM and Claude. The duplicate question is like the large language model will keep asking the same question. So it's not working if you want to generate or refine the explanation. So like these also cause some trouble in our iteration process. So now we involve fact-checking center experts, and the fact-checking center generate the explanation like this. They have a tag in the website saying that this is a fake news, and they say that this is the claim, and later they explain after investigation what they have. So here, what they do is they will follow some guidelines of generating explanations, these experts, and then they will consult other experts in the news domain. Like if it's health domain, they will consult health expert. If it's financial domain, they will consult financial expert. And then they will verify every evidence, then write this explanation. This is how they work every day, okay? And here is like the right side is very messy stuff. As you can see, even it's in Chinese, it's not in English. You can see like the right side, it's actually what we can see on the web page or the social media. It's not organized text. It's like written in a way that whatever people want to write. And the left side is here, you can see is the claim that has been rewritten by the expert, but it's a fake claim because they are trying to explain here, like this is the fake claim and what happened to this fake claim, like this. So the left side is the fake claim that has been organized by the experts. So here we find something also very interesting is that if you use the fake plan that organized by the experts, that works much better than you just crowd everything, this new claim in any form from the website, much better. Much better means like, let's show some, much better is like, here, news claims, as you can see, if we use our method, it actually can increase, like improve 78%. But if you do nothing, you just use the original post, it's a very big difference, as you can see here. So here we want to show you that if you have these nonsense question, as you can see, why this large language model cannot do well, they have nonsense question, like irrelevant question, and say no, and then they duplicate their question asking the same thing. These will cause this method dramatically in a like performance drop dramatically. So it's not good. And then if you use original post, same thing, it's not, the performance is not improved so much. So here, if we want to use this kind of iterative method, these experiment tells us that we need to organize the text first and then give the large language model. And then we need to avoid the automatic process. In the automatic process, that these nonsense questions show up. So we should remove these questions. If we can do it automatically, it's good, okay? So here's the result, another interesting result here. When we move to another language, as you can see, here, we'll see that we actually care about the graded percentage. That is, we hope that the flip rate is the highest, right? So after 48 hours, we want these memories keeps in the user's mind. So here you can see that the degraded rate from the expert is the highest. It's the highest, but others are like not too much difference. So as you can see here, first thing we know that from GPT-4 and non-expert, they are people, like real human beings, but they are just non-experts, okay? So their performance is like similar if you compare in the long term. But if you involve expert in this process to collaborate with the large language model, you actually has a much smaller degraded rate. Okay, so this is the place that we can really use experts' knowledge. All right, so this is our experiment here. So then we will ask the participants about their comments of using this, the whole system. And then like 60% of the users thinks that this can improve the clarity, and we actually reduce 40% of the explanation, because if you use the summarized method, actually they will summarize you a fixed length of articles, but in this way, they will just explain you from the aspects that you care about, and the users are satisfied, like 80%, 85% of them. Okay, so this is our that kind of like demo system. So it can work on many fake news, but we just put several examples here. So let me show you. Oh, can I direct? Can I? Yeah, I'm almost finished. Can I direct the link to? Yeah, I can. So, one. Okay. So these are some of the fake news. You know, the most interesting part of working on fake news is sometimes even I don't know it's a fake news, you know, after reading them, you know, it's a fake news. So here what we do is like, you can have one click and ask questions. So if you have one click, we have large language model work automatically asking questions for you and then generate the final explanation. And if you click ask a question, you can ask a question by yourself to the explanation. So if you're interested in this, you can play with it, but we only have five minutes left. So let me go back to my slides. How? Thank you.
You're welcome. There you go.
Oh, thank you. Okay, so this is what we think we can use these methods towards improving news literacy. So you know that there are also research in the education and the psycholinguistics. They are saying that the kids in school, they design some games for them to identify fake news so that they identify fake news better. So this is also something that we want to bring to the our next generation. If they use this kind of system, they will see how language model challenge your explanation. So in this process, they know how to challenge these explanation or like fake news claim. So we want them to learn this. And you will say that, oh, but large language model, they don't know what is the best way to challenge. But we already show you that if we work with the experts will challenge the large language model, and we collect this data. So we kind of can like fine-tune the argumentation process using this model. So this is what we think all these methods can help us and build the large language model to boost up the news literacy. Okay, so our future work, a very interesting aspect I will want to share with you is that all what we talk about are about the quality of the explanations, right? Because we are like people, human beings, we think that if we have a very good explanation, we can persuade people and change their mind. But we never talk about the quantity. I think that is because in the past, the quantity is not so easy to discuss because we don't have something that generates so high quality contents repeatedly in a different way, but now we have, right? So what we are working on right now is a very interesting research that we are trying to study that up to how many articles, like how many fake or how many real news, you can really change the perception of large language model, not human being, large language models. Because the large language model, they also collect all the information from the pool and decide and give you information, right? So they will also see like the fake and the real news, and people will ask them. So based on this, how many articles you need to change the large language model's perception? If you change the large language model's perception, it may change people's perception because people ask questions, right? And then now we also think that large language model kind of behaves similar to people. So if we have this conclusion, will people work in the same way? So that's the question we want to study next. Okay, so thank you so much for today's participants. This is my talk. Any questions? Welcome.
Thank you. Any questions? Yeah, go ahead. Yeah.
Hi, thank you for your interesting talk. So in the question generation, did you evaluate the quality or the relevance of the evidence that the questions gather for?
Yes, yes, we have several evaluation metrics, as you can see here. Actually, I just didn't talk about the details because of the time limitation. Oh, I didn't put it here. Well, actually, we evaluate like the correctness and the fluency, these kind of aspects too, like in the past research. But we just add more evaluation metrics like correctness and accuracy and the most important, the flip rate, what we want to know.
I'm specifically asking about retrieval part, evidence retrieval.
Oh, evidence retrieval part. Okay, this is not the focus of our research because we will assume that there are already evidence retrieved.
Yeah, but the
You
way
mean
you
like-
generate the question also affects the retrieval quality as well, right? So
The generated question, well, it will not affect the retrieval quality because the question generated is towards the explanation. So it gives the large language model these questions, and the large language model will look at this question and their original explanation and regenerate. So they, in general, will not do the retrieval one more time. Do I answer your question?
yeah, I'll follow up later.
Yeah.
I have another question if
Yeah, please go ahead.
So you mentioned about automatically removing nonsense questions.
Yes, yes.
Do you have some idea on how you might achieve that?
Yeah, there are some nonsense questions. First, there are some questions that are actually not fluent. And the second kind of nonsense question is that they are not relevant to this topic. I think we can use NLP technology to deal with it. And other nonsense questions, like I said, include that I don't have any questions. I think this is also noticed in many iterative large language model experiments for now, that people need to remove this kind of thing in the process. So I think they are all very similar, so we can do some of these filtering. Yeah.
Okay.
Questions?
Yeah.
Thank you for the talk, very insightful. I have one question related to the first experiment.
Yeah.
For us. You said something like for fake news, you need longer explanation, for true news, shorter explanation.
No, for fake news, you need argumentative process to generate explanation. But for real news, you just tell them the part, the fact part, just summarize the fact. That's enough.
Is this also based on their perception? So is, in a way, is this something you control, taking into account what they believe, if the news is true or not, or if the news is true or not?
Yeah, I believe so, but in the real application, in general, what we want to do is to make people not believe in fake news, right? So you know that it's a fake news, you want to make them not believe it. So you need to use like argumentative way. But for the real news, you just show them what is the exact thing in this news. That's enough. So kind of like confirm their impression about these real things. Yes.
Other questions? Maybe one last on my end. So you mentioned about how difficult it is to deal with data with people who haven't seen. So you talked about the fact that when you present to people non-fake news,
yeah,
it's more difficult to evaluate their satisfaction of response and so on because they know it already. So
yeah,
what would your thoughts be about dealing with emerging information, like something which would happen now immediately, and how your tools will be dealing with that?
You mean that how we deal with the one that we don't know?
Exactly. So given the dynamics of how information flows and specifically emerging topics.
Okay, let me explain a little bit because in my opinion, I don't think detection really works. Sorry about that, but I'm not talking about technology-wise, it doesn't work, but I apply it to the real system and you will find there are many political issues there. Like people will say, oh, you say it's fake because of you are another party. So this kind of thing. So eventually you need a real person, like authority to say, oh, this is fake, this is not fake. So, I mean, the detection part in general can be useful in the pre-screening process, but it's not really like useful in a real automatic online system. So what we have conducted from like 5 years ago is that we assume this detection has been conducted. And then from that part, we start to work on other methodology to try to change your perception. We think that the fake news is a little bit like a disease. So if you have infected, what you can do, what we see in my like real experience is that most of the system, they just remove this fake news. But it doesn't help because people already read it. So what we can do, so from the very beginning, we try to check this web note and push the real news to these people who have read the fake news. But from that point, starting from that point, we already know that this is a fake news, and maybe we already know from the web prints that you already read this news, and from there we start to see what we can do to make things better. So this is, yeah. So I don't work on the detection part, so I cannot really say about it. But even there's a very fast emerge fake news. I think there's still, yes, there are a detection system according to the misbehavior of this spreading, but there are still, it needs some agency or like authority to say like, this fake news, we need to stop it. Yeah. Thank you.
Thank you very much. Let's thank our speaker again.
Thank you.
And we're ready to move to the next talk, which will be the last for the first session before the coffee break. Okay, so the title of our next talk is, as you can see on the board, Network-Informed Prompt Engineering Against Organized Influence Campaigns Under Extreme Class Imbalance. And I'm happy to give the floor to Luca to present this talk.
Hello, everybody. I'm Luca Luceri. I'm an assistant professor at the University of Southern California Information Science Institute. I'm gonna present today this work titled Network-Informed Prompt Engineering Against Organized Influence Campaigns Under Extreme Class Imbalance. Very complicated title, so let's try to unpack it. Starting from the definition of organized influence campaigns. What are these? How do they work? What are the actors and mechanisms employed? Well, these are orchestrated campaigns carried out to mass manipulate public opinion, spreading propaganda, misinformation, and any sort of misleading, but even true information, trying to promote and artificially amplify certain narratives. So the caveat here is not only misinformation, but can be any form of content that can be and is artificially amplified within these campaigns. So how does it work? Well, the initiators of these campaigns create inauthentic personas, ranging from automated accounts like bots to human operators like state-sponsored trolls, to create, generate, and share content on social media platforms. And these actors work together in a coordinated way, trying to artificially amplify this content, making it more viral than it is, trying to create an illusion of public consensus, and also trying to manipulate platforms' feed algorithm, making content more viral than it is, and making content actually appearing in the feed of users. And then the problem is that, unfortunately, some organic legitimate users believe and trust and endorse and re-amplify the content generated by these malicious actors, which can eventually be picked up by mass media and news outlets. So why is this important? Well, because this talk is about detecting influence campaigns and trying to propose a novel method for the detection of these campaigns. Here is a short list. It's not comprehensive. It's mainly based on our prior work, based on the detection of these campaigns. We have mainly 3 categories, starting from unsupervised approaches that aim to detect these campaigns, especially when ground truth is not present, using network-based solutions. The second is based on supervised or semi-supervised algorithms, leveraging graph embeddings or graph neural networks. And the third one is based on LLMs, using a variety of methods, including zero-shot, few shots, and supervised fine-tuning. So I'll briefly give you an overview of where we are at and some of these solutions, trying to understand how we moved from our current work to the paper that I'm going to present today. So the first class is based on unsupervised network-based approaches. The main idea here is to create similarity graphs based on behavioral similarities in user behavior. The idea is that this network of similarity might capture abnormal similarities in user activities, looking at several behavioral traces, including similarities in the retweet activity, in the sharing of links or URLs, sharing of the same hashtags, particularly in the same sequence, similarity in the textual content produced by these accounts, and even the fusion, the combination of these different behavioral traces. How does it work? Well, the idea here is that these networks are used to filter out some nodes and edges based on some properties. Here are a couple of examples. You can filter out edges with a low weight, that is with a low similarity among nodes, or you can filter out nodes with very low centrality and look at the nodes that are at the core of this network. Now, in this example, we used verified campaigns. We used a dataset composed of verified campaigns, so we knew who were the malicious actors, the blue nodes, IO driver, and the organic users, the orange nodes. So we could find a good balance in the good filtering approach to basically filter out the orange nodes based on these network properties. In reality, most of the cases when we look at new data or unseen campaigns, we don't have ground truth. So the idea will be to evaluate the distribution of node centrality, evaluate the distribution of edge weights, and then find an appropriate filtering for these 2 metrics. Most of the time, we use a very conservative approach. We want to be cautious and we want to maximize precision rather than recall, because we want to be sure that the accounts that we classify as part of a campaign are indeed malicious actors. This work also, most importantly, as I said, is important to detect unseen campaigns and to uncover new coordinated actors. Lately, we also evaluated this approach across platforms. So not only on a single platform, but trying to uncover campaigns that span multiple platforms at the same time. So uncover this network that might be operated across Twitter, Telegram, Facebook, and many other platforms. If you're curious about this, we have a talk on Wednesday where we describe our results related to the recent US election and where we uncovered some of these campaigns across multiple platforms. So after this small advertisement, I can move on to the next class, which is based on supervised approaches. This can be semi-supervised, supervised based on the quantity of data available and ground truth available. The main idea here will be to utilize the network that we used in the unsupervised approach to build graph embeddings. Through that, we can train and test a classifier, like a state-of-the-art, off-the-shelf machine learning algorithm, and we can classify users as part of a campaign or not. This is an example with a graph embedding a technique like Node2Vec that allows us to have this low-dimensional representation of users in an embedding space that we can use, again, with a random forest or whatever machine learning classifier to basically detect users belonging to these campaigns or driving these campaigns. What are the applications of this supervised class? Well, first, we can use these methods when ground truth is available, or even a small part of ground truth data is available. However, it might suffer data scarcity and very imbalanced data sets. That's why we proposed a new algorithm, a new model based on graph neural networks, which tries to overcome this limitation. This is a paper recently presented at AAAI. The main idea here is to combine our structural properties from a similarity network with some language models and with language model embeddings in a new architecture that we proposed, where these two dimensions, these two modalities, the textual and the structural properties, the topological property of a similarity network, are combined through a cross-architectural layer and then concatenated and fed into a graph neural network model, again, to detect and classify users as either driver of a campaign or legitimate user. And this resulted in very accurate results. We tested these campaigns, we tested this model on multiple verified campaigns from Twitter, which were verified by Twitter and also defended against the US Congress, originated from many different countries. Here you can see 6 countries that we used for testing. And we compared these results with the Node2Vec, the previous approach, in data scarcity scenarios. So you can see here on the x-axis the percentage of training data and how the F1 score varies according to proportion of training data. What we found is that this algorithm is very effective in detecting accounts driving a campaign, even in scenarios with very few training data. You can see that in some countries, the gap between the blue line and the orange line is quite remarkable and it's quite significant, suggesting that this method can work in data scarcity scenarios. Great, you will say problem solved. Not really. We tried this approach for cross-campaign detection, for instance, using data from Russia to detect campaign in China or Iran. Sometimes it works, sometimes not. So there's room for improvement. And that's why we tried also to advance with other models. Going to the third class, language models, large language models can be helpful, not only for information literacy, but also maybe to help us uncovering these campaigns. This example is from last year's presentation at Beyond Fact, where we tried for the first time to use LLMs to classify users as part of a campaign or not. The idea here is to prompt our LLMs, it was Llama 2 at the time, with various information, including graph information like interaction or connection in a given graph, centrality measures, user metadata, and textual content shared by these accounts. This worked quite well for some campaigns, but it didn't generalize very well in a zero-shot setting. We tried with few shots, but we noticed that these might lead to some problems, especially in some cases, the selection of examples to be provided as few shots was leading to inconsistent results. And then we tried also a supervised fine-tuning, but it was not very sustainable, doable. It led us to promising results, but again, it's not very sustainable. It's probably infeasible to retrain models every time we have a new campaign and new data at our disposal. That's why we have, at the moment, we have a variety of methods. Each of them have some limitation in distinct scenarios. One method does not work well in cross-campaign detection. Another method works well maybe under data scarcity, but it has some problems with the limited ground truth or class imbalance. There's still work and room for improvement. And that's why in this work that we present today, we try to combine different facets, different components of our previous models, trying to understand if we can overcome this limitation and where we can advance. Now, take these results that I'll show you today as a very preliminary, as we are moving forward with this approach. But what's the idea? Well, the idea is to have a prompt informed by the graph. I don't know if you can see. Yeah, you can probably see this. By a graph, textual encoding, and a balanced RAG. These are the main two novelties of this approach. Now, we are going to unpack these, but the main idea is that we have a graph. It can be a propagation graph, a propagation tree. It can be a retweet network. It can be any sort of structural topological network that we might want to use for this specific task. And then we use these graph, and we try to encode this graph to a textual encoding, and we provide this information as an input for our final prompt, which also takes into account the original text to classify it as either part of a campaign or not. And then we have the balanced RAG that basically provides a balanced set of positive and negative samples. Let's go into the details of these, and let me try to unpack these in a moment. But just to tell you, we have this final prompt, and then we query the LLMs asking, okay, is this tweet part of a campaign? We can do the same with the user. Is this user part of a campaign or not? So the LLM basically has to perform a binary classification task. Okay, let's unpack this. Starting from the graph textual encoding, as I said, we have a propagation tree. We have a cascade of tweets that we want to study. We have a network of interaction. Whatever the input network is, we can encode these in a textual format. And this is a slide that basically summarizes different techniques to encode a graph. We tried a variety of these. We tried a few of them. The one that worked better is the one based on adjacency, that basically, based on a graph, it uses, it basically outputs a list of edges. As you can see here, the edges in a graph are, and then you have a sequence or a set of pair of edges, a pair of nodes that represent edges. This is a paper from Brian Perozzi from Google. Again, they explain a variety of techniques to perform this graph encoding. We tried a few of them, and this adjacency was the best one. Okay, let's move to the balanced RAG. The main idea here is to have a balanced set of examples to provide to our LLM. We want to have n samples from a positive class and n sample from a negative class, with the idea of overcoming some problems tied with the imbalanced data set that most of the time we encounter in our analysis. So that's how it works. In a nutshell, based on a training set, you try to build a graph embedding of these network structures. As we've seen before, this can be a propagation tree, can be a retweet network. You encode these using graph embedding techniques so that you have a multidimensional representation of your graph. You store these in a vector database. And then whenever you have a new input, you encode this input using the same techniques, again, a graph embedding technique like Node2Vec, and then you compute the similarity between your input and the representation, the network representations you have in your database. You compute similarities, it can be cosine similarity, which is the one that you use, but you can also have other techniques, including text similarity, and then you retrieve a balanced set of examples, and for the positive class and for the negative class. And the main idea is that you use the most positive samples for each class. And then you provide these samples to the LLM, which then will return an output. This is an example of the final prompt. As you see, you have an original prompt, the original prompt question, which basically asks the LLM to classify a tweet as either fake or part of a campaign or not. We use the label fake and real. We provide the original text, and we provide the tree-based graph or the graph textual encoding as a list of edges. And it's not displayed here for the sake of simplicity, but you have also as input to the LLM the balanced RAG outputs, that is our positive and negative samples. And then the LLM basically outputs a class as either fake or real. These are the results, and take this as a very preliminary set of results. We have basically two classes of algorithms that we want to test. The first four are graph-based algorithms that take into account the graph only. The second class are different variations of our model, considering a Llama, a 70 billion LLM, with different settings starting from zero shot, few shot, RAG, and our balanced RAG, which is the last row in this table. First observation, the graph-only solutions are not performing very well and are often or always beaten by LLMs-based solutions. As we move from zero shot to few shots, performance improves. Importantly, and most importantly for what is the scope of this work, the balanced RAG is providing us with the best results, suggesting that having a balanced set of examples leads to better results. Of course, here recall is pretty high, precision is still not great, but again, this is work in progress. This is something we are currently working on, trying also to understand what's the role of LLMs and actually of the size of LLMs. We in this plot we show how the performance improves when increasing the size of parameters in our LLMs. You can see that results dramatically improves when we move from very small models to larger models. And of course, this might be an indicator that further increasing this model size, we can do even better. We performed an ablation study trying to understand how these different components impact the results. As I said before, without text, so only graph approaches do not perform that well. But still, we can notice that combining text and graph leads to better results. Only text approaches, that is the first row in this table, do not lead to results comparable to when we mix, where we combine text and graph. Again, this is to show the capabilities and potential of this approach. We notice that text plus graph and a balanced RAG leads to better performance. So concluding, these are the takeaways. Text alone is not enough when looking at these problems. Structural properties from networks and interaction networks are particularly important. Contextual information provided by RAG and examples increases the performance, especially when the examples are very well balanced, trying also to mitigate problems like extreme class imbalance. Finally, we have seen that larger LLMs lead to better classification performance, but the main question for our future work is, can we do that without relying on extremely large models? Can we still improve our, not so small, but still not huge models, and lead them to better results? That's that's what we are working on currently. And I'm gonna stop here, giving you just other quick information. I mentioned the paper. I don't know why these slides look odd, but anyway, quick information that might be helpful for this community. We have been working on an initiative related to the past US election, where we collected a bunch of data from many different platforms, including TikTok, Telegram, Twitter, Truth Social, etc. These are widely available. We have a paper that will be presented on Wednesday, as I said. Stop me and let's chat at any time if you want to know more about this. Thank you.
Thank you again.
Any questions? Start with one maybe. So actually I have two of them, but let's start with the first one. I was wondering regarding the specific campaigns in terms of the results of the LLM. So did you look into that, for example, like language topic specificity? Could this be an influence with regard to the results? You mentioned that there were some cases that were better than others.
Yes, you're completely right, and I think this slide here should somehow be enhanced to have a better representation of these differences. Well, these campaigns are very different from each other, not only in terms of language, because you can see that they come from very different areas of the globe, but also in terms of targets. Some of these campaigns try to be political and attack some certain candidates. Some others also have different strategies. I talked before about the network that try to artificially amplify content through retweets. Some other network use URLs. So it's a very diverse setting where different campaigns have very different tactics, very different topics, very different language. So as of now, it's very difficult to understand which one led to better results or not. Sometimes it's also the composition of the dataset. Class imbalance is one of the factors that I mentioned. Some of these campaigns are some of these datasets are very imbalanced with a very tiny proportion of users. This is another, of users driving a campaign versus organic legitimate users. So all these things play a role. We don't know yet which one of these factors might lead to better results or not.
Questions? Yes, please.
Thank you for this interesting talk. I have a question about the Llama model. Are you using Llama?
Yes. So in our first approach, we used Llama 2. In this last, it's based on Llama 3. Where is it? Yeah, this one is based on Llama 3.
I'm interested in the balance RAG issue because in the recent research, there are a lot of discussion about how we should put the information in the RAG, right? So what do you find if you are not using balance RAG? Why it causes this performance harm?
Well, what do we find when the RAG is not balanced is this raw. The idea there is that we provide an unbalanced set of examples to the LLMs. Why the balanced version works better than the other? My assumption is that we provide the LLMs with better information and qualitatively more aligned with the scope of this detection, because with the balanced RAG, we basically give the LLM the most similar networks or text to the input. So we have this component based on similarity of content and networks that might allow us to, or might allow the LLM to better extract patterns or traits from the input that align with a given class or not. But going back to the decision of using one LLM rather than the other, again, this is a very preliminary result of this approach. We aim to expand this to many different LLMs, as you showed before. Some LLMs might be more suitable for some scenarios, some others not. So it's work in progress, but yeah, good point.
So like samples you actually put in RAG,
Yes. Yes. Yeah, we have 6 shot, so 6 examples per class. And I think also this is something we tried with different number of samples.
Not a question, it's more of an idea. What do you think if you kind of compare the collections before and after Gemini, will there be the same practice or maybe different patterns?
Before and after January?
Gemini, so for example, 2020 election and 2020.
Oh, yeah. I believe we will see very different things.
I think that because let's say the version of it was 2022, So it's just 2 years. Do you think that the last 2
The,
years?
I can't hear. Can you say again? The first?
First.
Uh-huh. Oh, yeah. That's why I'm saying I think we will see very different things in the tactics used by these initiators of these campaigns. I truly believe that nowadays they rely on more sophisticated tools like LLMs. So if we compare the tactics from 2020 to now, as we have done in the paper that we have a presentation on Wednesday, we will see very different tactics. Potentially these coordinated actors leverage sophisticated LLMs. So it might be, and I'm pretty sure and confident that there will be very different patterns in their coordination activity, very new tactics that leverage these language models. It's not present in this slide because this is work in progress. We have an ongoing work on TikTok, and we discovered clusters of users, which is basically this cover here of my presentation, using AI-generated voice. You cannot see anything, but it's just a cluster from TikTok. They use AI-generated voices over some videos with captions and over with videos that are completely the same. Some of these are pretty sure AI-generated. So we see this trend on very different platforms as well. So your point is completely right. Yeah.
Right, so I suggest that we stop here for this morning. Thank you again, Luca. We meet you here back at 11. Coffee break is already running.
You like kingdoms, maybe no, but no, my problem is I cannot write so many people this week, previous week.
They also get
So it's so hard to put tickets, so I have to fly like a couple days.
also yeah, so you've been around for
Like 2-3 days.
Yes.
Yes, a couple times. And how about you?
I would like to put the power on the computer.
Oh, yeah, sure.
Oh, but there is no. Hmm. Because I don't think. Or should we change this computer and set up the new one? Oh, what is this? But there is no free. This is the camera. There is no free slot.
So if I add the other reports that are like this because there's not enough room. So my suggestion that you use your
But then we need to change it now.
Yeah, we need to change the setting.
Yeah, yeah.
Shall we use your computer?
Yeah,
work.
we can.
Let's do that, right?
Нямам къде са другите презентациите, ако се наложи да ги пуснем.
Те са на моя компютър и на един USB ключ.
Дай да ги прехвърлим, защото да сме готови. Да сме готови по-добре, защото...
So, you want to change the computers?
О, no.
Ah, okay. Yeah, just send a short message to the online people, say that you're on coffee break.